Hi everyone. Let's dive to our second question. Next question of the SD sheet, right? So it's trapping the rainwater. Okay. So let's see uh, what's happening. Actually, that I submitted this code just a few minutes back. So you can see this. It passed efficiently, right? Now let's see the question first, right? Trapping the rainwater. So this question comes under hard category. And given n non-negative integers means that our test cases are going to be positive. Let's see the constraints of this question. The constraints are like that. The array will contain minimum 0. Maximum could be 10 to the power 5. So one thing which we can conclude that O of n square would not work here. Time complexity, right? And now uh, so we are given a non-negative integers representing an elevation map where the width of the each bar is 1. So it's something like this, right? And compute how much water it can trap after rain. So let me explain with this example. This input says that the height has 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. So the height of the zeroth, what is this? It's a kind of map, elevation map. Height of zeroth element is 0, right? And height of first element is 1. Second element is 0. I can see here that there is no element, I mean black box here present. So since we can see that this 0 has a boundary on the left side, which is 1, and a boundary on the right side, which is 2, right? So this can store water. And how much it will store? It will store something like the minimum of both of these. Let me show you with the pen. Minimum of this. You see this? This is the minimum element here, and it has boundary on the left side like this, 1, and right side is 2. And it will store how much water it will store? Maximum, I mean minimum of both of them, right? So this will store 2 minus 1, which is 1. I mean 2 minus 1, which is 1, but first we will find what is the minimum of both of these maps, right? Okay, so minimum is 1. And then we will find 1 minus 0, right? So it comes about to 1. So this will store uh, 1 unit of water. Okay, and then let's move on to our first third element, 2. Now let's see what's the case here. I can see that it says something like that. Okay, so the left side has maximum wall is 1 on the left side. Okay, and on the right side is also 1. So I don't think the water is going to stay here because water will spill down from here to here and then here. No water will be remaining, right? And from this side also, the water will fall here, here, here. Ah, so this third third element cannot store water because left and right boundaries are not present properly, right? Now let's move on to our fourth element, which is 1. Now see how much is the left boundary of this fifth element. This is left boundary is 2 and rightmost boundary, I mean the highest boundary on the right side is 3, right? So it will store how much? Minimum if of both of these boundaries, which is 3 and 2 of it. Should draw it from downside. Minimum of these two, because the both of these are the maximum height, right? So 3 and 2. But the minimum is 2, right? And then 2 minus 1. So it will store around 1 unit of water. So you can see here, it's 1 unit. Fine. Then now let's move on to our next element, next index. So it's 0. It's a sixth element, right? Now let's, yeah, let's see how much this can store. Leftmost boundary from this sixth element is this is right, 0, 1, 2, 3. Fifth element. Fifth element is 2, because this was the maximum height which we had found, right? On the right side is 3. So what is the minimum of both of them? 3 and 2. The minimum is 2, right? Since we calculated it earlier. And now 2 minus 0, we will just subtract these two, since the index is, the index on which we are finding how much water it can store is sixth, and therefore we will subtract this one from the minimum of the both of the boundaries. So the answer comes out to be 2 minus 0, which is uh, 2, right? So you can see here, it is storing 1 plus 1 unit. So now it's about 2 units. Fine. Now let's move on to our seventh index of the error. Yeah. Yes, yes, yes. Come on. Seventh index. Seventh index is this one, right? Yeah. What is the left most highest boundary on the left side? Same, it's 2, right? What is the rightmost, I mean, highest boundary on the right side? It's 3. Minimum is 2, means again minus 1 minus 2, which is 1. So this seventh index will also store 1 unit of water. Same file. Now let's move on to our next element, which is this most highest element, which is 3 of of this window. Yep. Wait. So our current element is the eighth element, which is 3. And what is the leftmost highest boundary on the left side? It is, I don't find anyone. So I don't think this will store any water, right? Any drop of water will flow from here to here and here, and then it will be wasted, right? On the right side also, there is no boundary. So it will be wasted. Okay. Now since there are no boundaries on the left and right, which are greater than this, we will simply move on to the next element, which is ninth element. Now let's see what happens at the index height 9. What I can see here is index 9. What are you saying? It says that the element at the index 9 is 2, and the left side is 3. And rightmost boundary is how much? 2. And 3 minus 2, how much is that? 3 and 2. What is the maximum of both of them? 2, because the maximum boundary of the right side of this ninth element is 2, right? Yes. So, and minimum is 2. So 2 minus 2, which is 0. So all the water will be spilled from here to here, right? I will not draw further. Now let's move on to our next element, which is 11th element, I guess. Wait, it's ninth element, right? Okay. And what is the leftmost highest boundary of this? Nearest and highest boundary. That is 2. And rightmost highest boundary. That is also 2. And what is the minimum of both of them? Both of these boundaries. The minimum is 2 because both are same, right? So no one is the minimum. Answer is 2. So 2 minus 1. Therefore, it will store only 1 unit of water. Fine. Now let's move on to the next element. Yes. So now we are on 10th index, right? This one. This 2. Left side nearest and biggest. I mean, maybe nearest or the farthest. But what is the leftmost highest boundary on of this 10th element? It is 3, right? What is the maximum of the right side? It is 1. So what is the minimum of both of them? It is 1 and it is less than 2, right? So water will also spill from here to here. This is a waste. Okay. Now let's move on to the last index, which is 11th index. On the left side, I can see 2. Yeah, it is left boundary is there. And what about the right boundary? Is there a right boundary? No, there is no right boundary. So what will happen is it will not store any portion of water. Everything will be flown and wasted from here. It will spill out, right? Now, in this simple code, I have coded here. Okay, and you can see that the answer is 1 plus 1, which is 2, 3, 4, 5, 6. And the answer is also 6. Okay. So now let me tell you this. What is the solution of this? In tuition, I have already told. Let me tell you how I stored this. Okay. s- What I did is, first of all, I took the length of this array, given array, right? And then I declared a maximum temp. I made a maximum left array, which will store the maximum of the, maximum of the left part of this array. What is the maximum of the left of this? Let me draw it. Let me write it for you, Sam, right? So first is max L. Max L. The left highest element on the left for tracking the left boundary, right? So I declared it like something. I the motive was to find the motive was to find the boundary of the left side, right? Since the what would be the boundary of this zeroth? Zero, because simply what is the element of left side of the zero, which is greater than zero? No, nothing is there, so it is zero, right? And then that's 1 I plus plus. Here, what is the highest element on the left side of this one? That is also zero. Okay, then now let's 1 again I plus plus. What is the highest element on the left side of this second element? It is 1. Okay, then I declare it to 1. Nice. Then what I did is again I plus plus, and I saw that there is a 2. But what is the highest element in the left side of 2? It is 1, right? This, fine. So I wrote 2 on the third index. Fine. Then, oh yes, then I plus plus. Now, what do you think? What is the highest element on the left side of this fifth element? It is 2, right? Because maximum of this is 2. Wait. I mistakenly wrote here 2, right? Let me cancel this. So this will be 1. Oh, sorry for this one. Yes. And now after when we mark the highest position of this third element, I move to the right fifth element. I mean fourth element, right? So what was here? Here I found that the element on the left side, which is highest, is 2. So it should be 2, right? Now since 2, here will be 2, here will be 2, right? Here also will be 2. Let me write it simply so that you guys are not wasting any time in doing simple stuffs. Okay, let me simplify. Okay. So, so other two. Yeah. So now you are done with the rules. Now when we are on this index, what is the highest element selection? It is 3. So from this index, the highest element of the left side changes. It becomes 3. And here also it becomes 3. Until the end, the highest element on the left side will remain 3. Okay. Yeah, fine. And now let's find the maximum element on the right side of the array. For this case, what I did was I just started from s- second last index and declared a max temp named uh, variable which contained -1. And I kept updating this ith element of this max R array with the maximum of this temporary and height of ith variable, ith array, ith element of the array, right? So what I did was simple. There were arrays, right? And there was a -1. Initially, okay, wait. Let me draw this -1 here because this was the main helper on the zeroth index. And since I have declared array in Java, so initially every element of Java contains 0, right? So it is the property of Java, right? Wait, it looks something like L. To write it like 1. So okay, wait. Let me write here properly temp is equals to 1. And and this variable temp1, I use this variable for both of the arrays. Temp, I declared this temp with -1 initially in both the arrays. temp has -1, right? Okay, yeah, no, temp, yeah. I declare this max temp as -1 for both of them. For left index, left array also, and max right array also. Okay. And I started iterating this from the, this was already 0, right? And I was here, my ith index was here, and the second last element, a second last index of R, and also at the second last index of this uh, height array, right? And here the eraser, let me erase this so that I can explain this properly. Yes. So yeah, my I was on this, which is second last, which is I -2 initial. I kept updating it with max of I -1 and temp. So what is the maximum here? It's 0. Wait. No, no. What is the maximum of this temp and this I -1? It is 1. So we will be writing here. And okay, now our I will shift to I minus minus. Let me see there. Yeah, it's I goes to I minus minus, which is third last, right? Yeah. Since I updated this with the temp, I also updated this one. I updated the temp with maximum of these, which became 1. Then again, I am updating this max temp with uh, maximum of I-1, I+1, which is this. Uh, mm, wait, yes. I+1 and maximum of this. Wait, no. And the other I was tracking it from not here. I was tracking them from maximum temp and this one. This I+1. Yes. So this is I+1, right? So the maximum of I+1 and temp, how much is it? It is 2. So this will be rated like 2. Now let's do this do this wait. So hmm, move this I to here, right? And move this I to here. So now what I did was I then went to maximum of this max is also updated to 2. Then I updated this ith of this max R as temp, right? Temp had this 2 after the I minus, right? Now since the temp is having this much value and I+1 is having 1, what is the maximum here? The maximum is 2, right? So this will also have 2. Now let's do a let's do an I plus let's do an I minus minus. So where will our I go? I will go Yes, I will be moving from. Let me raise this. It's disturbing a lot. Simply, what is the thing that I am having? I, I plus one and 10. I am keeping decreasing the ith element index of the max R and this height array, and then update the max R of ith element as the maximum of temp and height. Okay, that's right. So I moved to here, right? Our index is I minus 1, I minus 2, I minus 3, I minus 4, I minus 5. So it's around something like here. Uh, yes. So what is the maximum of this portion? Maximum of the right side of this is 2, right? And maximum of the temp and 2 is also 2. Yeah. So I updated this with 2, right? Simple. No problem. Very easy question. Nothing at all. Most easiest question I've ever found. This was submitted without TLE on the first attempt. Okay. Now I'm moving to the I minus minus in the index. Now it's saying that, oh yeah, our max is also 2 here. Now, since our I has been moved to, since our I have been moved to this position, now, what do you think is uh, I plus 1? This one, 3. And what do you think is maximum? It's 2. So what is the maximum of both of them? Math dot max of I plus 1 and temp, it is 3. So we will update this with 3, right? Yeah, fine. So simply I did this with this max R and kept updating the ith index, and ultimately I got the array which had the maximum of the left side of all the elements, right? So for this 0, what do you think will come out as the answer? Will be 3, will be 3, will be 3, will be 3, and still it will be 3, still it will be 3. So therefore our left index gets filled with max of right gets filled with threes, lots of threes, until it reaches zeroth index, right? 3. Oh, yeah, that's 3, right? Okay, it's 3. Let me see if I'm going out of bound. So indeed, I am not out of bound. I'm just okay. So in this way, I got the maximum of the left and maximum of the right. Yeah. One. another another 3. So let me paste this one also. Yes, first small. Now the index is there must be 7 3s according to the calculation which I have done right now. Uh, 6. So we need to put one more 3. Let's insert this inside the array. Oh, sorry. Small. Oh, yes. So 7 3s, 3 2s, which are this, this. Yes, 1 2 3, 3 2s, and 1 1 1 0. So since this was a dry run, now let's what I did indeed problem. Let me show you that. What I did is uh so this is the code for I equals to 1. I said I started from this one, first element, not the zeroth. Because the zeroth element had nothing on the left side of it. Therefore, the maximum of the left side of this zeroth element will be 0. Therefore, let me let me say that, yeah. And then I declared a temp -1. As you can see here. Yeah. And then I kept updating this max temp with the height of I -1. And even in the one previous of this original array and the temp. And then I update this max L with the max temp. So ultimately I got this array after that. Hmm, hmm. Similarly, I did the similar thing for this. For with max of right. Uh, what I do was I went to the second last element, right? And then I compared it with the last element and the max temp. And I updated with the maximum of the both of them. Since initially the last element was 0, because I did nothing with that in the max R, therefore it got updated to the maximum of the right side, right? And not -1. So simply I kept decreasing this I minus minus until it became equal to 0 and updated that with max of the tenth. So nothing new, simple, similar approach, right? And then for finding the answer, what I did was I declared a variable named answer, and then I traversed it from height of I, which was our initial index, initial array, right? Then what I did was, if I was smaller than minimum of both of them, which I was doing here, right? You see here, I is smaller than minimum of both of them. Therefore, it was storing minimum minus the height, right? So I did the similar thing. If the height of I is less than minimum of max of left and max of right, I mean both of the array, what we would do was answer was plus is equals to at dot minimum of both of them and subtracted from the height of I, right? And then what I did was return the answer. Now let me show you by running it. In this way, passed all the test cases. Let me So yes, this one. Okay. Let me show you by submitting it. So since 1 millisecond taken, submitted properly, 324 test cases have been passed. And let's analyze the time complexity of this solution. Since we are traversing the array only one time, which is O of n, therefore, this is linear time complexity. Time complexity is O of n. You see here, this loop is going only once, single loop. This is also single loop. This is also a single loop. So O of n plus O of n plus O of n is nothing but O of n only, right? And let's talk about this space complexity. Space complexity is that what we did was I created these two elements and two arrays. Space complexity which I took was O of n, right? So similar O of n space complexity, O of n time complexity. Problem is submitted. Thank you very much. Meet you next time.